Hello, my name is Fernando Melean, and this is my 112 term project presentation. I designed a program called Ice Rush, and it's very similar to an ice puzzle, except that it attempts to help children practice their multiplication and addition. And the way it attempts to achieve this is by having them solve for an expression that's displayed at the top, and then move on the ice towards that expression. And then it will show them an animation just like this that attempts to create a visual representation of whatever expression they just solved. When they get an incorrect number, however, they won't not only get points, but they'll also lose points and get a strike up there in the top right corner. Another issue is that sometimes when they get to level 50 or something, they might have difficulty solving the puzzle more than they actually out solving the math. And even though that's important, it's less important than math, so they can access a hint. And the way that works is that if they click on any one of the goals, a second penguin will appear and show them how to get there. Now, beyond the tutorial, I can show you the gameplay. I mentioned before, in addition to multiplication, I have an option for addition. And the way this displays it is instead of constructing a box, it will construct 3 strands. The first one will show the first 2 numbers, the second one will show a more compressed version, and the last one will show the answer. As I was entering that, you probably saw that I have 4 difficulty settings. I have 3rd through 5th grade, and I have college. The way these differ is that the higher the difficulty, the larger the set of numbers that these 2 factors may be drawn from. And the other difference is that the game will grow much more difficult much more quickly, as I will show you now. So as you can see, once you get to a higher level, the numbers at the top get much bigger, and also the screen gets a lot more complicated in the motions you can take. And one thing that makes this important is that you have a lot more of these false goals, and this affects the generation of random boards because it must be solvable for each and every one of these, as I can show you now. You see, it's solvable for each of them, but the problem with this design choice is that it's very hard to find a board that can be solvable for each of them because it's very constrained. And that means that my board generation is very slow. So the way I tackle this is that I set a time limit, and if it passes this, it will just give up and use a board from a past level. It's that it will move around the correct solution to a different area. So like you could go here, or this could be here, so it's different every time. The other issue is that it is guaranteed to be solvable from your starting position, but it might not be solvable from other positions. And what we do then is that if you ask for a hint when it's no longer solvable, it will simply skip straight to the animation and then deduct some points. And these are all the features I'd like to show you today. Thank you for watching my presentation. Have a nice winter break.